Well, it's good to be here at the conference, and I mean that. And I've been places and talked to folks, and I told them the same thing, and I was lying. This is a really unique group of folks, and I mean that when I say when I've met the people I've met here, and truly genuine. Greg and Cindy, I don't know what to say about those guys, but they are special, and this is a special group of people. So my name is Bill Riddle. Grew up on a farm, finished a 4-year degree at Oregon State University in animal science with a crop science minor. I went to the family farm in 1990. One of the benefits to going to university was I found a wife there, and she followed me to the farm, and we raised 4 kids. And we farmed for 30 years. It was a family corporation. So when I got to the farm in 90, it's about 2,500 acres. Most of that was owned. When I retired, after some fun family dynamics, in 2020, I started looking. I knew I'd have another career. Well, in 2018, I met a guy named Dr. Robert Faust. And for those of you that were in Edmonton last year, you saw Bob present. We were farming his land, and he wanted to do a little trial. So I met Dr. Faust, and right up front, I knew he was nuts. Bob talked about the Humic model of farming and farming with humus. And he talked about Rudolf Steiner. And he talked about biodynamic agriculture. And I thought to myself, here's a guy, some crazy old guy, telling me, who has a 4-year science degree that's been growing crops for 30 years, how to farm. But I was fascinated. So in 2020, when we left the farm, my first phone call was to Dr. Robert Faust. And within a few months, I was working with BioAg. And that began my learning of living soil. So I'll credit him to get my knowledge my learning started. And I am a student. I'm not an organic chemist. I'm not a geologist. But I am a learner. So I'm going to credit guys like Greg and Glenn Rabenberg and Dr. Tom Dykstra for teaching me how to unlearn what the university taught me and all the agronomists that I worked with over the years. And that process is still going on. Greg asked for me to talk today a little bit about humic substance. Again, I'm not an organic chemist. I had a full year of it at university back in the day, and I remembered none of it. And now, every day, that's what I work with. So I wish I'd done a little better work in school. Okay, I'm clicking. Which button? Humic substances, a relatively large, complex, mostly carbon molecules that function in the soil system as concentrated organic matter and are stable across a wide pH range. The Humic Products Trade Association calls them the dark-colored substances that remain after the natural biodegradation of biomatter and whose distinct characteristics are their relative resistance to further biodegradation and are highly heterogeneous and their highly heterogeneous molecular structure. So there's a lot of confusion in the world about humic acids. And I know up here in Canada, there are lots of humic mines, lots of humic products. I had a little bit of experience with humic substance before I started working with BioAg. But my goal here today is to just simplify this and give everyone here an idea about how to evaluate those things and how they work. So they are chemically rich and complex, but they don't have to be complicated. So this slide up here is just to show how complex they really are. So there are 800 or more organic compounds from 6 functional groups. So, and this lists, so humic substance can be broke down into humic acids, fulvic acids, omic acid, which I'm not familiar with that chemistry, and humin is the insoluble portion of humic acid. All of these functional groups, the carboxylic groups, phenolic groups, the aromatics, all of these, and there's amino acids, excuse me, that's just a portion of what's in humic substance. When we talk about humic substance and humus, so these things exist in a lot of places, in the soil and in raw materials. But generally speaking, when you hear about a humic product, it's solubilized from leonardite or lignite, which is soft coal, usually associated with a coal mine, but leonardite can be laid down in layers all by itself. And it's a stable carbon, and the biomass that makes up humic substance can be a full range of grasses, deciduous trees, evergreen trees, and they're not all the same. Humic substances, as we apply them, are considered biostimulants at the rates we apply them. Considered a multifaceted organic magnet that functions in the rhizosphere as a buffer, bridge, conduit between the inorganic clay, mineral, microelement components in the soil system and the living organic microbiome of the soil. So if you think about, and guys are starting to learn this with their composting, that when you add clays and you're able to combine that with humate or humic or organic acids, that composting becomes a lot more productive and there's more humus created. If you think of, so inorganic minerals and the microbiome, all of the biology, the fungal species, all the bacterial species, if you think of this complex carbon molecule as the bridge, it's a food source, it's a buffer, but it's that bridge between biology and the inorganic portion of soils. It is the magic. It is the black stuff. We saw pictures of soils earlier, Brian's soils. Where'd Brian go? There's Brian. The black, the sticky that causes aggregation in soils, that's the magic, and that is humus. Humic acid is just a form that we can add to drive the system. People will claim that you can change the EC of your soil with humic substance, that you can change your organic matter content in your soils, but they truly function as a biostimulant. They are a starter that drives the system and begins cycling living soil. But they're the magic in the end. I'm going to move into fulvic. So they can contain 800 or more organic compounds from 6 functional groups that are associated with 3 unique components: humic acids, fulvic acids, and humin. These components are defined by their molecular weight and solubility in water. I don't mean to get complicated here, but basically, if a humic molecule is the size of this room, and I'll show you an example, and it's a small example. If a humic molecule is the size of this room, a fulvic molecule is about the size of one of these tables, okay? All humic acids eventually, over time, in a biological system, will break down into a fulvic-sized molecule. Now, a fulvic molecule can pass through the plasma in a plant, through the leaf tissue, highly available, and it has the ability to complex elements. The humic molecule can be really large, but over time, in a living soil, it will break down into fulvic components. So you can this isn't a great analogy, but it's okay. That if you think of humic as this crude oil, and you all in Canada understand that pretty well, fulvic acids would be a refined gasoline. I really don't like that analogy. But it gives you the color, and that color thing is kind of what you see. So here's an example of a humic molecule, the different organic compounds that it breaks down into or has present in it, and then a fulvic acid. The scale of that should be about 10 times what it is or more, just to give you an idea of how complex a humic molecule is. But simply, fulvic is the fulvic acid that comes out of a humic molecule or associated with a humic substance is the magic that drives the soil system. So humic sources, it's in your soil. If there's any life in your soil, there is stable carbon, complex carbon present. We've done a pretty decent job of burning the carbon out of our soils, so there's a lot less there than there was in a commercial system. You can find it in composted manures at a little higher concentration. With peat, we use some peat in our processing, but the biggest form, or there are many more products built out of leonardite than anything else. And the source matters. It matters what kind of functional groups are in your humic acids or humic substance. There are negative effects in humic substance. There are ethyl groups and methyl groups that can be a problem in soils and in plant production. But there's just an example. There's a peat bog there. Leonardite, it can be found all by itself, not associated with a coal mine, but pretty commonly it's that upper level. And basically it was huge amounts of biomass that was laid down and degraded in a very controlled environment because it was capped with a clay or a sand, and that's where it comes from. Here's a study by a group in Russia, and when I say the source matters with humates, they broke it down into biologically active portions of the humate, and you can see there's a huge range of what is considered biologically active, the different functional groups, and so I want to communicate to you all today that where your humates come from is a very important question to ask because they're not all the same. My first experience with humates was 22 or 3 years ago. Agronomist shows up on the farm with a half a pallet of 2.5 gallon jugs of this black stuff. We applied it. Spring planted tall fescue. I didn't tell you much about my farm. You don't really need to know that much, but spring planted tall fescue. We do grasses for seed, turf type and forage type grasses. It's always a trick to get tall fescue in the ground early enough that it can make it through our dry summers. Because when the rain shuts off in our part of the world in June, we don't see another drop of rain until middle of September, October. That is standard. So you do a spring planted crop like tall fescue, And you just hope it's going to make it through the season, right? And if it gets up quick, got some tillers on it, it can handle some heat because we get hot, right, Greg? We got hot last summer. Anyway, put some of this humic out. I don't know if it was a 10-acre. It was a fairly good-sized field, and it was a pretty good test block. Fescue comes up. It's clean. It looks fine. It's growing. The humic-treated stuff, and it was only humic. It was probably humic with some 1034. We watered it down a little bit. And I don't remember the rate of the humic. Crops up, growing well. Midsummer, it's got 4 or 5 tillers. If it can get to 5 or 6 tillers, it'll make it through, even if it gets hot. And we'll get to hundreds, right? What would that be in Celsius? 30. And it'll stay there for a bit. Well, that happened this summer. And we watched that crop burn off, except the humic treated. So we thought, we're in the money. We got this figured out, right? Give me more of that stuff. The next year, we're going to use it on everything. What did we see? And I don't know if it's the same brand or not. Nothing. And we did that for 2 more years, and we saw 0 response. And that is proof that not all humates are created equal. Whatever that first stuff was, and it was a different brand, it worked, and it worked really well. And that was about root growth and soil biology and all of that. But it really matters where your humic sources come from. Okay, one more thing I'm going to cover here is, so at BioAg, we do a lot more things than humics and fulvics. We are a plant biostimulant company. We have a number of products. And one of them that I think would be a really great fit for this part of the world, very low use rate product, is this TM7 liquid. So Dr. Faust developed TM7 many years ago, but as a dry product that would go into soil mixes, mixed with fertilizer, a prill that you could throw or mix into potting soils types of thing, landscaping, or not landscape, but nursery crops. But now we've solubilized it into a liquid. And it includes 7 micronutrients. Because another part of this living soil system, beyond balancing soil-based saturation, to allow air and water, get the physical properties of your soil fixed. Another thing that can be limiting is the availability of critical micronutrients in the rhizosphere, particularly the root zone, both for a developing plant and for microbial life. So microbes also use trace elements. And anyway, it's an idea, throw it out to you guys, that this could be a good option for broadacre stuff. And we do it a lot. We're doing a lot in the valley. I threw in one more picture here because, so we have a product called Evolostrum. And Evolostrum is a pretty high use rate product that's humic, it's listed there, heavy humic, fulvic, so our full power product, 2 aminos, silicon, kelp, micropack of micronutrients. And I was thinking to myself, this trial happened 2 years ago, and it was a OOPS trial, which we all love, when in this case, the liquid pump broke on the drill, and grower called me and said, you gotta come see this. The reason I'm comparing this to what you guys are doing with your extracts, fish, micros, silica, this product's kind of the same. Similar input. Anyway, went to the field, I'll finish the story quickly, went to the field, and 100 couple acres, planted in lands. The headlands, the pump broke. So we had a full trip all the way around the field that, you know, the computer didn't pick up, that you, when driving down the highway, you could see it for, you know, for a quarter mile. You could see this light strip all the way around the field. Well, we went and looked and we dug samples, and then I find out later, and this field's up, you know, that's, you know, 4 or 5 tillers planted, fall planted. I find out later that the grower had thrown 80 units of nitrogen on this field right after planting, before it ever emerged. So it was really interesting to me to see how those plants responded in a really high nitrogen situation. I mean, that's a lot, that's way more nitrogen than you should ever throw in the fall, but that's what they did. Anyway, the earthworm population, the soil tilth, completely different with just one application. But I bring this slide just to share with you guys, this is something really similar to what you're doing with your compost teas, etc. So that's about all I have. Questions?
Seven micronutrients you have in the 3M7, please. They're quite unique.
I'm going to have to.
Come on, Bill.
Sorry, it's Greg. I don't want to have to get through all these. Okay, I'll do it from memory. Fine. And please don't quote me on this, guys. I really, okay. Because we've got one that we build in the amino acids, and we've got this pack that's different. Iron,
Do you want me to bail you out?
copper, zinc,
Boron, cobalt, copper, iron, manganese, moly, and zinc.
thank you. Heavy sulfur, heavy boron, and heavy zinc, right? There's 3 that are heavy. Thank you, Greg. Like 1% versus, or yeah, 1% versus a 1/4% of the pack.
The reason that I'm interested and I wanted to talk about this is the moly for your nodules. Moly's essential for formation of nodules. And played a little bit before about that. Moly is expensive and hard to come by. And the other one is cobalt that's very unique, and but that's on the conversion of nitrogen for the cobalt. They're hard to come by, and there's not very many products that have it. And it's easy to put in, and it's in a humic acid. That's all I'm saying.
Perfect, Greg. Thank you. Hey, any questions for me? Farmer Bill answering questions about complex organic chemistry. Is everybody clear on that? Does that help at all? Just that quick description of humic substance? A little? Come on, Brian. Say a little? Okay. Well, I hope it did. Does anyone have any questions for me about BioAg or... You know, I met Greg 2 years ago. Am I stealing time now? Not quite. We started working with Hybrix Manufacturing 2 years ago. Greg came down. He was surprised. You ready for me, Lauren?
Okay.
We're close. And it was kind of a match made in heaven. This giant guy, my wife calls him a Viking. He looks like a Viking. He shows up and again, Greg, thank you. Glenn, I see you peeking around the corner. And Dr. Dykstra. These guys are helping me unlearn. And that's a good thing, because I'm learning about a whole new way that soils function. And I know you all are too. Okay, thank you.